Thank you, Nicole. Good morning, everyone. Thank you all for attending. I'm excited to be here to talk about Guardrail. This will be rather informal. If you have any questions or thoughts during my presentation, please feel free to put a comment in the chat box or to raise your hand or just try to get Nicole or Janet's attention, and we will make sure that you get your question asked, and I will do everything within my power to answer today. And if I don't have the answer today, I will find the answer for you and I can share it with you at a later time. So again, I'm excited to be here and thank you all for attending. So today we're going to talk about Guardrail 101, new standards, crash testing, and installation. As Nicole said, my name is Ryan Tenges. I'm the Highway Safety Engineer with the Federal Highway Administration, the Kentucky Division Office. We're located in Frankfort. We work very closely with the Transportation Cabinet, I hope everyone is staying safe at home these days. Let's get started. So, maybe we'll get started. There we go. Here's the agenda we have for today. First, we're just going to go over some roadside design basics. Looking at our crash data, is there a specific problem that's related to roadside or fixed objects? And if there is, what do we do about it? Are there other options we have other than just installing Guardrail? And if none of those other options work, when should we actually use Guardrail? And then we're going to get into some MASH and N-terminal testing, talking about the new requirements of the Manual for Assessing Safety Hardware. What has KYTC done in response to this change in the testing requirements? And what steps do all jurisdictions, locals, states, MPOs, everybody else need to take to be in line? So let's just hop right in. Roadside design basics. Let's look at some 2019 crash data first. In 2019, the state of Kentucky had nearly 157,000 total crashes. 698 of those actually resulted in 766 people losing their lives. Looking at roadway departure crashes, that's just over 27,500 of those crashes. So it's about 18% of the total crashes. However, 344 of those roadway departure crashes resulted in the loss of 357 lives. This actually accounts for about 49% of the total fatal collisions, as well as 47% of the total fatalities. So this shows we have an overrepresentation of our roadway departure crashes here in Kentucky. The number one thing that people run into or collide with when they have a roadway departure event is a fixed object. Now, roadway departure crashes are generally more severe simply because people are colliding with these fixed objects. So we have to do something to help with that situation. So here's some options we have to reduce those fixed object crashes in order of preference. We're going to go through each one of these. First is remove or relocate the obstacle. Obviously, simple, straightforward. If the obstacle isn't there, you can't hit it, so then it won't be a problem anymore. And then, of course, on top of that, the further away that you move an obstacle from the roadway, the less likely it is to be hit as well. What's the number one object that we hit here in Kentucky when we have a roadway departure event? Our beautiful trees that line our rural roadways. An existing tree that has an expected mature size that's greater than 4 inches, we consider that to be a fixed object. And obviously, when you have a 1-inch diameter sapling, it's much cheaper and it's easier to remove that than it is when that tree becomes a 12-inch trunk that may have environmental or political consequence. So our recommendation, as well as KYTC, is to mow or cut them down when they're small and they're no big deal. The next option we have is to make the roadside traversable. If there's got to be an obstacle on the roadside, then build it so that an errant vehicle can traverse over the obstacle without snagging or overturning. The general rule here is if it's taller than 4 inches, it could be a snagging issue and you need to either remove it or make it shorter than that 4 inches. So we all have these on our roadways. You know, we'll have a large tree that we want to remove, and we need to have someone come out and do that. And when they do it, hopefully they don't just leave a stump like this. It's much higher than 4 inches tall, still leaving a potential hazard there on your roadside. If you remove a tree, be sure to grind the stump down to be less than 4 inches in height. And then we have an instance like this. You have a traversable slope that would give the driver the ability to recover if they have a roadside or have a roadway departure event. But then if they get down to the bottom of this slope, they hit this large head wall that's sticking up. There's many projects that are done within the state. The HSIP group, Highway Safety Improvement Program group, looks at roadway departure corridors. And one of the most common things that they find are large head walls like this. And what they do to correct that, they either remove the head wall and they extend the pipe out, or they remove the head wall and make it to be the same slope as the slope that already exists, thereby making it traversable, giving the traveling public the ability to recover instead of snagging on it, rolling over, and flipping, potentially having a severe or fatal crash. The next option we have is to reduce impact severity. Simply here, you make the fixed object breakaway. If you can't move it, you just make it breakaway. You try to soften the impact any way you possibly could. One of the ways we normally do this is our breakaway signposts. As you can see in this picture, you have two signposts, both of which are breakaway. They're spaced far enough apart that the standard vehicle would not be able to strike both of them at the same time. So that is very well designed, very well done. But then you have this problem right here in the middle. If I can move my cursor over it, you have a head wall right there behind it that looks to be taller than 4 inches. So you may be able to just reduce the impact severity, but also look in the roadside as well to see if there's other things that you need to do to make things traversable. The next option you have is to shield the obstacles. So this is number 5 out of our priority list. This is where you'd use guardrail or concrete barriers or crash cushions. These barriers are used to shield the motorist from a greater hazard. However, they are a hazard in themselves. So we need to think about that. The thing that they are shielding, are they a greater hazard than the object that they're actually shielding, or are they actually doing a service to the traveling public by protecting them from something worse? So we need to remember that. We need to consider guardrail and other barriers to be a hazard. So with that in mind, you have an instance here, looks like a practically brand new roadway with some very new guardrail as well. When you look at the picture, it's very difficult to determine what that guardrail is actually protecting. Simply because I don't see anything right there on the roadside right behind the guardrail. I don't see anything at the bottom of the slope. The slope looks traversable. This could be an instance where the original design was for the slope to be non-recoverable, maybe a 2-to-1 slope. And maybe the contractor found an opportunity to waste some extra material and make that slope more traversable. So I just show this picture to say, just because you have guardrail planned to be there, if there's something else that can be done to do it, to remove that guardrail, please do that. Guardrail itself is a hazard as well. There's no reason to have it out there if it's not shielding anything. The last option we have, if you can't do anything else, at a minimum, we want you to attempt to make the object more visible, putting a marker on it or a delineation of some sort. Here's an example of a project that was done in Marion County on a local rural road. As you can see, this is a pretty standard looking roadway for our roads here in Kentucky. Just has trees lining both sides, very narrow. So what do we want to do? We want to remove those trees. So here's what they did. They widened the roadway out a little bit, got a little bit more of a shoulder. They took out a bunch of the trees except for one. I don't know why one tree was left, but sometimes that's just the nature of it, whether it be political or environmental issues, no one knows. But for this instance, they couldn't remove the one tree, so what they do, they put this one delineation or one delineator on it, an object marker, to make it more visible for the traveling public. So let's look at these again. Like I said, guardrail is not always the #1 choice. There are 4 other options you can do before you do guardrail. Remove the obstacle, relocate it, make the roadside more traversable, reduce the impact severity, and then shield or use guardrail or another barrier of some sort. And then the last option would be to delineate the obstacle. Now, thinking about using barriers, one of the most important things when you're using barriers is to ensure that the distance between the barrier and the hazard is the distance that you need. And that's based upon what type of barrier you're using and what you're actually protecting. So each barrier has a different deflection. These are the 3 types of barriers that are commonly used here in Kentucky. A flexible barrier, which has a deflection over 5 feet, sometimes anywhere up to 12 feet. A semi-rigid type has a deflection of 2 to 5 feet. And a rigid type has more of a deflection in the range of about 0 to 1 foot. So here's an example of flexible barrier that everyone probably here on our webinar has seen across the state of Kentucky. This is our cable barrier. We have this in the medians across the Commonwealth and lots of our interstates, as well as some of our parkways. Here in Lexington, where I live, we also have it on New Circle Road. So it's very common. This has a design deflection of up to 8 feet, sometimes 10, sometimes even 12. So that's something to be aware of if you're looking to use that. Semi-rigid barrier is what we call our WBeam barrier. Our standard WBeam barrier has a deflection design of about 3 feet. So we need to be aware of that when we are using that out in the traveled way. And last but not least, the rigid barrier, which is our concrete barrier, which is behind our crash cushion here, that has a deflection of about 0 to 1 foot. So that's very rigid and not very forgiving. Now thinking about all these deflections that we just talked about, can anyone see a potential hazard in this picture? It's probably maybe a little bit difficult to see in the picture itself, but we do have a string of guardrail that is right in front of that line of trees. And if that is the case, obviously these trees are, if they're immediately behind that guardrail, which appears to be unanchored and have no, it's not a very strong string of guardrail when I say that it's not anchored, which means that it may actually deflect more than the 3 feet that we designed. So if someone hits that guardrail and it deflects, it may actually deflect right into those trees, causing a severe crash or maybe a fatality. Obviously, that's not what we want. One of the very important aspects of guardrail installation is grading the earth and ground around our new end treatment. There are 3 different types of grading that we want to focus on. You have advanced grading, you have adjacent grading, and you have runout grading. Our advanced grading is it must be applied to the terrain over which the vehicle may travel before contact with the barrier terminal. As you can see in the picture, it's right there in front of the end terminal. This area should be no steeper than 10 to 1, so essentially making it flat to ensure that a vehicle is stable at the moment of impact and that its suspension is neither extended nor compressed when it interacts with that end terminal. Now, adjacent grading, it refers to the area on which the terminal is installed and the area immediately behind it. As you can see here, that is the area highlighted. Ideally, this area should be essentially flat as well, 10 to 1 or even flatter, so the terrain itself does not increase the vehicle roll, pitch, or yaw upon impact and interaction with that terminal. You want to make sure that's as flat as possible.
Hey, Ryan,
yes?
Comment in the chat here.
Okay.
David says, we have observed Alabama DOT utilizing quick deployment water-filled barrier to shield damaged guardrail sections until crews can mobilize to repair the damaged guardrail. Would KYTC be open to exploring this quick and temporary positive protection mitigation method?
That's a very good question. I have seen across the country many different states that do very similar things. Indiana does something similar as well. I'm not sure about Kentucky's stance. Right now, I think that what they currently do is they just put out some orange barrels, just kind of to delineate the situation, make sure that people know that there has been a guardrail strike there, and the guardrail may not respond in the way that it's designed to. I can speak with construction as well as maintenance about that and see what they if they've have any thoughts on that, or if they've been interested in the past. That's a good question. I'll look into that.
Thank you.
Looking again at the runout grading, this is the grading that refers to the area into which an impacting vehicle may travel after actually breaking through a gating terminal. So if they strike the terminal within the first post or two, the design is for that terminal to just gate and to open up and allow them to travel safely behind the string of guardrail. The physical extent of this area needed, it varies depending on the vehicle size, speed, impact angle, driver reaction, terrain character, and terminal type. So you just want this area to be as large, flat, and free of objects as you possibly can be, because you never know which type of vehicle will actually end up hitting your guardrail. So looking at the grading requirements for the end treatment type 1, the tangent end treatment terminal for KYTC. This is their standard drawing. As you can see, it shows In the advanced area, you have your 10-to-1. In the adjacent area, you also have 10-to-1. And then in the runout area, it says desirable of slope 4-to-1, 3-to-1 max. So making it 4-to-1 means that it can be recoverable. 3-to-1 means that it's traversable but not recoverable. So it should not cause, if it's 3-to-1, it should not cause a vehicle to roll over or cause another crash in that respect. Same for type 4. As you can see, you have 10-to-1 in your advanced, you have 10-to-1 in your adjacent, and then again for your run out, you have 4-to-1 desirable, 3-to-1 max. Now, a lot of questions that I've received from other people that have gone through a similar training with me on this, there's lots of places across the state where we cannot get this grading. It's very difficult in mountainous areas and in areas where you don't have much of a shoulder, you just go directly into a ditch. It's very difficult to get these gradings completed. So what the question always is, what should we do in that instance? Well, the answer is just do the best you can. You want it to be as close to the design and the standard drawing as possible, but it's understandable if it's not entirely able to be built up that much. But like I said, you just want to do the best you can with what you have. All right. Now looking at the minimum length of guardrail, there are several statements across many of the different standard drawings for KYTC, and they all have a very similar note. Minimum length of guardrail, including the end treatment preceding a fixed object, should always be 200 feet. Why does it say 200 feet? It says 200 feet because guardrail needs about 100 feet of guardrail on an anchored string of rail to build up enough tensile strength to withstand a crash. So the thought process is here, when you have 200 feet, the thought process is that you could strike that guardrail anywhere on that guardrail and you'd have at least 100 feet in one of the two directions, upstream or downstream from where you hit it, that it would be able to withstand the crash. So that's why we have 200 feet. And I highly encourage not only KYTC to continue to follow this, but other jurisdictions as well. You need to have at least 100 to 200 feet to withstand a crash. Now, looking at our end treatments that we're going to talk about, you have, I don't know if everybody knows this, but there's an order of preference of the guardrail end treatments that KYTC uses. The first or most preferred is the type 3, the barrier anchored on the back slope, or the type 2, which is barrier against a solid rock face. These eliminate end-on impacts. They're both generic materials, but non-proprietary. This next preferred is the flared end treatment, the type 4A. It's flared away from traffic and it's a gating end treatment. And the last is the straight line or tangent end treatment, the type 1. It's energy absorbing and it's closest to the roadway. The reason why these are in this order, the ones on the top are the furthest away from the roadway, which means that they're least likely to be hit and they're least likely to have to be repaired at a regular basis. With a type 1, it's only a few feet away sometimes from the edge of the shoulder. A type 3 and a type 2 could be up to almost 50 to 100 feet away from the edge of the shoulder. So that's why these are preferred. They're much easier to maintain because they're further away from the roadway and won't be hit nearly as often. With that, I think we had a poll question here, Nicole. I don't know if we can, how do I see those answers, Nicole?
You want the question?
I'm sorry. I'll share the results with you once they're done. Once they
okay.
On the poll. Can everybody see the poll question?
You're talking about the MASH question?
Yes.
On question 1, yeah. Oh, wait. Janet?
Here we go. I can see it.
Okay.
This is the next thing we're going to talk about, MASH. It's the Manual for Assessing Safety Hardware, and it's new requirements that we have for crash terminal or for end terminal crash testing. So I kind of wanted to gauge everyone's experience with that, if they've actually heard of it and have used it or looked into it at all. Okay, so we've got a lot of people that have at least heard of it. This is good. This gives me a pretty good idea. So we've got 2/3 of the people have at least heard of it. So that's good. I can work with that. Thanks, Nicole, for putting that up there. I appreciate that. And then we can minimize that here. And then we can move along here. So let's look at this a little bit here, if I can get my computer to work again. All right. So we have had crash testing standards in place since 1981 when we first started using NCHRP 230. And that was in place until 1993 when NCHRP 350 was published. And generally, that's the one that people are most familiar with. In 2009, the first MASH, MASH 09 was published. And then the second edition of MASH came out in October of 2016. When MASH was first adopted in 09, AASHTO and FHWA agreed that it was only an incremental change to NCHRP 350. And that current hardware that was already meeting 350 could continue to be installed. However, all newly developed hardware was tested to that new requirements under MASH, but there were no deadlines that were set for converting to state standards. It's now 11 years. It's been 11 years since MASH first came out. And now there's quite a number of devices that have been tested to that new standard. But as long as the states continue to allow the older devices, private industry had no real incentive to spend money necessary to test their new devices to meet the MASH requirements. In order to move forward and get more of these new devices out in the field, FHWA and AASHTO came to an agreement that it was time to fully implement the MASH requirements. There's many reasons why we made the change. The screen shows one of them. Excuse me. The truck on the left is the vehicle, the pickup truck that was used for crash testing in NCHRP 350. The vehicle on the right is the pickup truck that has been used. That's the new pickup truck that is used for MASH testing. Question for everyone. You guys can put it in the chat pod. What are some of the differences you see between the truck on the left and the truck on the right? Don't be shy. Don't anybody write the differences Chevy versus Dodge.
Let's see.
Height, good.
Height.
Larger, good. I like it.
Okay, you can see.
Height and wheelbase width, very good. I like it. Height, bumper height, yep. So you guys are hitting them all right on the head. Ground clearance, that's right, Mr. Gossam, you've been through this before, it appears. The vehicle, the truck on the right, it's got a much higher bumper, a higher center of gravity, and it's larger than the vehicle on the left. And it's more in line with what we're seeing today in our vehicle fleet. So that was one of the reasons why we moved forward with the change to the new MASH requirements. On your screen now, you should be able to see a slide showing the difference in sizes between the small car and the pickup truck for the NCHRP 350 testing versus the new MASH testing. As you can see, the vehicles on the left for NCHRP 350 are much smaller, they weigh less, they're closer to the ground. The vehicles on the right, even the passenger car, is significantly larger and heavier than the previous in 350, as well as the pickup truck. The pickup truck is now a 4-door pickup truck, as opposed to the 350 was only a 2-door. So that's another major change as well. So the big question, what are we testing when we do these crash tests? When we test the crash, or we crash test an end terminal, we're making sure it does two things. Render the end of the barrier safe when it's impacted head on, and it needs to provide anchorage. Anchorage is giving it the additional strength, which is given by that the cable that you can see in this picture down here. This is called the terminal end cable here. Here is a picture of the 7 tests that are done for an end terminal through MASH. You have test 30 and 31, which is your standard end head-on collision. 32 and 33 are a 5-degree angle collision with the end terminal as well. This is a pretty significant change from 350. Test 34 is your critical impact point test. This is where it's striking there right near the end terminal, not head on, but at a 15-degree angle. So this is going to test the ability for the end terminal to gate and what happens when the vehicle hits it that close to the end terminal. Test 35 is a 25-degree angle that's striking at the beginning of the length of knee. This is really testing your anchorage. the strength of your system, the strength of your end terminal. And test 37 is the opposite direction strike at a 25-degree angle as well. It's testing what happens when it's struck in the opposite direction. Will you have any snagging? Will you have any issues? What will happen? This slide kind of shows the new requirements that were set aside in the AASHTO FHWA implementation agreement. The agreement set forth the following dates, and as of these dates, all contracts, both master and project, that were let on the National Highway System, which is a subset of our roadways here in Kentucky, must install MASH-approved hardware. Did not cover existing master agreements or maintenance efforts that were underway at that time. However, the implementation agreement did strongly encourage state DOTs to upgrade or replace their damaged hardware with MASH-approved hardware through maintenance and state force efforts. Now, I know that this is only specific to state DOTs, and I know we have other jurisdictions, locals, and others that are on our webinar today. And what I can stress or encourage you all to do is to upgrade your guardrail as well, so that we have similar systems between the state system and the local system. We know that along several roadways, many roadways across the Commonwealth, we have guardrail that's rather low or that has been used past its useful life. And if you have any guardrail like that in your jurisdiction, I recommend reviewing it, see if it needs to be upgraded. Now, what I do stress when I show this is that these new standards don't mean necessarily that current guardrail that we have out there will not shield obstacles and protect the public as it's designed. Existing guardrail systems are not dangerous or faulty. That's not what this means. Sometimes when people see this, they think, oh my gosh, I need to replace all of these, all my guardrail, all of my barriers, everything out there because they're no longer safe. But that's not what this means. This simply means that there are new testing requirements, and if your rail, your guardrail, is at least 27 inches in height, it probably is still working the way that it is designed to do. And that is based on the Highway Design Manual, and the Roadside Design Guide makes that same statement. So if it's at least 27 inches tall, it should still be able to function the way that we need it to function. Federal Highway started to track how states were, how well they were working with these new implementation dates. So that's kind of what you're seeing here on this screen. As you can see, as the implementation dates got later, there was there were many more issues with state DOTs, whether or not they felt like they were going to be able to meet those sunset dates. And as you can tell, the last sunset date of December 31st, 2019, which kind of covered everything else that wasn't covered in previous sunset dates, states had the most issue with. So there's lots of questions that came out from that. Because there were so many questions and concerns, there was actually a Q&A website that was put together by AASHTO. This gave state transportation authorities the ability to go to a website to look up their concern and ask more questions. Actually, you can submit questions through this website as well. And they gave them the ability to find out what they should do in their situations. With that sunset date, December 31st, 2019, the major issues that many states had, there was a very limited number of MASH 2016 compliant devices that were available in several of the categories that were listed. And some of the existing compliant devices may not actually meet the requirements and the needs of the transportation authorities. So AASHTO and FHWA worked together, and we created some exceptions to allow some MASH 2009 compliant as well as NCHRP 350 compliant devices to be used in their place. And I had a question to ask here, and I think that we have enough people that were aware of MASH, so we could ask this question. So Nicole, if you have that question available, would you mind to ask that for me?
Right, let's see here. Oh, wait.
I think it may be the next question, Nicole. It was about, were you aware of these exceptions, or I don't remember the exact verbiage that we had. There we go.
Okay.
It's about 50-50, okay. The slide I have up on my screen currently lists a lot of the flexibilities and the exceptions that FHWA and AASHTO agreed to in this situation. And I'm not going to sit here and read this all for you. I will make sure that Nicole or Janet sends this out so you all can have a copy of this and be able to see it for yourself and know what you're able to do to still be in accordance with the MASH requirements. So thank you, Nicole, for doing that poll for me. I appreciate that.
You're welcome.
Let's go back here to our presentation. Along with that, there were some requirements that came along with these flexibilities regarding some of the required documentation, other things that people have to do when it comes to the use of MASH 2009 or NCHRP 350 devices. So again, like I said, I'll make sure that everyone can get a copy of this presentation if they want it so they can see all this information. So let's get into what did KYTC do in response? How did they respond to these changes with MASH? Well, the first thing they did was send out a state highway engineer memo in November of 2017, where they made the decision to switch from their strong post WBeam Guardrail system to using the Midwest Guardrail system. Midwest Guardrail system is rail that is at 31 inches high. KYTC old standard was at 29. It has 6-foot post length, space is 6'3", which is still exactly the same as what KYTC had in their previous strong post WBeam system. It has 8-inch offset blocks instead of 6-inch. What that means is that your posts are 2 inches further away from the roadway and vehicles than they were previously, giving hopefully a lesser chance of those of your tires and your wheels snagging on some of those guardrail posts when they have a crash. The splice location change. The splice location means that where the two panels of guardrail are connected and come together on the old strong post WBeam system, they did that at the post. And the problem with that was it created the point of greatest strain and greatest stress in the guardrail system itself to be at that point right there on that post. And when you did that, it kind of weakened the system. It didn't make the system as strong as it possibly could be and made a greater opportunity for that system to tear that guardrail right there at that point. So changing that splice location to be mid-span instead of at the post, it makes the system stronger and gives it a greater ability to withstand those crashes. The Midwest Guardrail system also does not have that requirement to have the additional 1-foot shoulder widening behind the guardrail. So it's a stronger system and gives greater strength when you have a crash. Like I said, these are some of the reasons I just kind of went over. Your mid-span splices, your reduced post embedment, that just means you don't have to spend as much time on installation. You don't have to spend as much time drilling those posts in. Your increased mounting height, now it's up to 31 inches instead of 29. Your increased blockout depth. The standard design, also this is a big one for the Midwest Guardrail system. Its standard design can be used in a wider range of application, not just in your standard situation. When you have different situations with curb and other things that come up, you can just use your standard design. You don't have to change anything. Also, there were also current end treatments already in place that KYTC was familiar with. They could use with the Midwest Guardrail system as well. So here's a couple pictures of the Midwest Guardrail system. The picture on the left shows one of those applications where it's a non-standard situation, but you're still using your standard design with that curb. And on the right, it's just a standard installation with a tangent end terminal, type 1. So here's a standard drawing showing many of the things that we talked about before. You can see your mid-span splice location, and you can see the 31-inch height, as well as different blockout sizes. What did KYTC do for their type 1 end treatments? They changed them. Used to be ET Plus and the SKT. They moved on now to make the soft stop and the MSKT be their tangent or type 1 end treatments. And here is a couple pictures of those. I'm not going to go real in depth on these. My partner Ryan Gossam and I, we have another training that we do where we go very in depth on how to install these bolt by bolt and looking at each individual post. If you're interested in that, I can make sure that everyone is aware of our next class that we do. But MSKT is here on the left and the soft stop is on the right. As you can see, they look very different. And the soft